Hi all. So very good evening. So the topic of today discussion is vector. In last class we discussed about unit and dimension, and there I guess we discuss all the relevant concept related to unit and dimensions. Right? There are some question which we need to discuss, so that we will discuss in later part of this lecture, which is recently asked in JEE Mains. Right? So first we will discuss about vectors. So you know that in previous class we discussed about physical quantity, right? So there we discussed that any quantity which can be measured, right, is called physical quantity. For example, velocity, right, current, uh, torque, all these are physical quantity. So now we further classified physical quantity on the basis of direction and magnitude. So for that reason, we need to understand what is vector. Okay. So see, vector is nothing but it is a physical quantity which has magnitude and direction, as well as it follows triangle law of addition. What is vector? A physical quantity, a physical quantity which has magnitude and direction and obeys triangle law of addition. Triangle law of addition. Now you might have wondering that what is triangle law of addition, right? So which we study in today class, that what is actually triangle law of addition. So for till then, understand that any quantity which has direction and magnitude and always triangle of addition is called vector. Because in I think in ninth and 10th class you might have studied that this definition, that any quantity which has magnitude and direction is called vector, but that is not the correct definition of vector. For a physical quantity being a vector, he needs to follow vector law of addition or triangle law of addition. The other famous example, current. You can take example of current. Why current is not a vector? Why? Because current doesn't follow triangle law of addition. Current has direction, current has magnitude, but it does not follow triangle of addition. For that reason, current is not a vector. So now if someone asks you what is vector, you need to add that any quantity, any physical quantity that has direction and magnitude and always triangle law of addition is called vector, right? Okay. And a scalar, what is a scalar? A scalar is that physical quantity, a physical quantity which has only magnitude. Is called scalar quantity. मतलब all those physical quantity, right, which has only magnitude. For example, let's consider a speed. We generally represent a speed as v, right? So if some suppose there is person Kritika and there is another person Rohan. Kritika moves with the speed of 5 meter per second and Rohan moves with the speed 4 meter per second. Suppose Kritika is moving in the direction of east and Rohan is moving in the direction of west. Suppose this is Kritika moving with the speed 5 meter per second and this is Rohan moving with the speed 4 meter per second. She is moving in east and this Rohan is moving in west. Okay. Do direction anyhow impact their speed? Motion? No. Because speed is a scalar quantity. There is no any relevance of direction in case of speed. That's why we say speed is a scalar quantity. Okay. So any physical quantity which has only magnitude is called scalar quantity. But those quantity which has magnitude as well as direction is called vector, right? Let's consider some more examples. Suppose there is a block. This is a block where we put a pressure of 5 Newton in the direction of east, and there is another person who also exert a force of 4 Newton on it. So what will be the net force here? F net equals to 5 Newton plus 4 Newton. That means 9 Newton. Now let's take another example. This is the same block where a person exert a pressure of 5 Newton in the direction of east, and another person B exerts pressure of 4 Newton in the direction of west. Now what will be the net effect of force on this block? The net effects of force on this block will be F net equal to 5 Newton minus 4 Newton, that means 1 Newton. Here you can see by changing the direction, our net force, the magnitude of net force has changed, right? So this is how we can interpret that force is a vector quantity, because here you can see that as I change the direction, the net effect of force is changed. So this is how this is how direction impacts the vector quantity, right? So you might have wondering that how we can say this is vector quantity or this is scalar quantity. So for that reason you need to understanding that any quantity which has direction and magnitude is called scalar vector quantity. And with the with some time you will get aware of that this is vector quantity and this is scalar quantity. There's not there's not a big problem in it. You will easily understand that this is vector and this is scalar. You don't have to remember all that mass is scalar quantity, velocity is vector quantity, current is scalar quantity, displacement is vector quantity. You don't have to remember that. You need to develop analytical thinking, right? You don't have to remember these things. This is for those student this is for someone who is not in who is not from science background or something, is from arts or commerce background. Then he has to learn all this or remember all these things. You don't have to remember, you just have to develop an analytical thinking that this is how we can say that this is vector and this is scalar. That's all. So yeah, so now you understood that what is vector and what is scalar, right? Now let's discuss how we represent a vector quantity. How we can represent vector quantity. So representation of vector quantity. See, there are two ways to represent a vector quantity. First is an analytical approach, and second one is graphically, or you know graphically, or we can say diagrammatically. So there are two ways to represent a vector, graphically and analytically. Now we will discuss first analytically approach to represent vector quantity. For analytical representation of any vector quantity, you just have to write, suppose A is a vector quantity. A is a vector quantity. So how you will write it? A arrow. This is the analytical representation of vector quantity. A arrow. Now let's understand graphically or diagrammatically. So diagrammatically, if you have to represent a vector quantity, suppose A is a vector quantity, so diagrammatically we can write it as this. This is A vector. This is called tail and this is called head. So this is how we can represent any vector diagrammatically, right? Suppose we have to write 2A vector diagrammatically. How you will represent it? See, A vector is this, then 2A means what? 2 times of A vector, right? So the length of this vector becomes double. Now this is what? Tail, and this is what? Head. So this is 2A vector. So in this way we can represent any vector quantity diagrammatically. So this is how we can represent any vector quantity. So there are two ways, graphically and analytically, right? Okay, now let's understand shifting or parallel shifting of vector quantity. So before that, let me ask you one question. Suppose A is a vector. So if we shift this vector like this, this is also A. We have not changed the direction. We have not changed the magnitude or length of this. So what will impact on vector? What will be the net effect or impact of vector? There will be no any impact on vector. Why? Because we have not changed the direction. We have not changed the magnitude. So we can say that if direction and magnitude is constant or same, there will be no any impact if we shift the vector. So this is what we call parallel shifting of vector. This is what? Parallel shifting of vector. Parallel shifting of vector. You can say this is B vector. So you can parallelly shift it as B, 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 B. There will be no any impact on the vector. Why? Because you have you have not changed the direction, you have not changed the magnitude. So this is what we call parallel shifting of vector. Now the question arises that what is the use of parallel shifting? What is the use of parallel shifting? So now we will understand the use of parallel shifting. So before that, we need to understand angle between vectors. Angle between vectors. Angle between vectors. So okay, so hold on. Before this, we need to discuss some, how we can represent different vectors. So hold on. Okay, represent these vectors. First, a vector of magnitude 5 meter per second in the east direction. A vector of magnitude 4 meter per second in the north of east. Suppose 5 meter per second is a vector and you have to represent it as 30 degree north of east. So how we can represent these vectors? The first one is a vector of magnitude 5 meter per second in the east direction. So the first we can represent it as, suppose the 5 meter per second vector is a vector equal to 5 meter per second in the east. So we can simply represent it as a vector 5 meter per second. Right, this is the tail and this is the head. Now the second question is a vector of magnitude 4 meter per second in the north of east. A vector of 4 meter per second in the north of east. Right, so you know that this is east, this is west, this is north, and this is what? South. And we have to represent a vector of magnitude 4 meter per second in the north of east. So north of east will be what? This angle, this. So let's consider this is B. So B is 4 meter per second in the north of east. This will be the angle north of east, from east to north. North of east means what? If a person moves from east to north, that is north of east, right? So let's consider this is theta. So theta is the angle between north of east. Okay, now the third one is 5 meter per second north of east. 5 meter per second north of east. So see, this is east, west, north and south. So what is our question? 30 degree north of east. So this angle will be 30 degree, and this is what 30 degree north of east. So let's consider this as C vector. So C vector is 30 degree north of east. So in this way we can represent vectors. So now let's move to the you know angle between vectors. How we can calculate angle between two vectors? Angle between two vectors, or angle between vectors. Okay, so the question is, we have understood that we can represent graphically any vector. Suppose A is a vector like this, and B is vector like this, and we have this is A vector and this is B vector, and we have to calculate angle between A and B. So how we can calculate that angle? See, angle between any two vectors is nothing but angle between two heads or two tails. Angle between two vectors is nothing but angle between their heads or either tails. Angle between their heads or either tails. Now we discussed about parallel shifting of vector. So angle between two vectors is nothing but angle between two heads or two tails, right? So see here, you can see that this is the head of A vector and this is the tail of B vector. So this is the angle. Can we say that this is the angle between vector A and vector B? No, we can't say that. Why? Because we just understood that angle between two vectors is nothing but angle between their heads or their tails. Here it is angle between head of vector A and tail of vector V, right? So this can't be the angle between vectors. So how we can find out the angle? So we can apply the concept of parallel shifting here. You know that if a B vector is here, so we can parallelly shift this like this. This is B and this is A. How? We have applied the concept of parallel shifting. How? I told you earlier that in parallel shifting there can't be any change on net effect of vector. The direction is same, magnitude is same, so we can parallelly shift the vector. So what I did here, I just shift this vector V from here to here. So this is the angle between vector A and vector V. Let's say this is theta. So theta is the angle between vector A and vector B. So if you have to find out angle between two vectors, you just have to align their tail or head. Then the angle between these two are called angle between vectors. So here what I did, I joined the tail to tail of vector A and tail of vector B. So this angle is called angle between vectors. Or either we can do another thing, that we can join their heads. We can join their heads. How? See, this is our A vector and this is our B vector. This is A and this is B. So if we apply the concept of parallel shifting, so let's join their heads. We can shift this B vector as this. Now this is B and this is A. So now these two heads, aligned or joined. So this angle will be the theta and this is the angle between two vectors. So if you have to, calculate angle between any two vectors, you just have to join their heads or tails. Then the angle they make with the one another is called angle between vectors. Okay. See, suppose this is A vector, this is B vector, and this is what? C vector. If you have to calculate, suppose this is theta, this is alpha, and this is beta. So angle between vector A and vector B. How we can calculate angle between a vector A and vector B? See here, head of vector A and tail of vector B is, joined. So we have to write it as, this is A. We can parallelly shift it as like this, B. Now we know that this is theta, and on a straight line we know that the angle on a straight line is 180 degree. So this angle will be 180 degree minus theta. So here angle between A and B is 180 degree minus theta. Now let's calculate angle between B and C. B and C vector. How we can calculate angle between B and C? See, here C is what? This is C. And B is what? This is our B. Can we say that this is the angle between B and C vector? No, because here head of B and tail of C are joined. Not head to head, not tail to tail. So what we have to do? We have to join either head to head or tail to tail. Then only we can calculate, angle between B and C vector. And as I told you, this angle is alpha. Now apply the concept of parallel shifting here. This is C. Now we can parallelly shift B vector as it. Now this is B vector. We know that this angle is what? Alpha. So this angle will be what? 180 degree minus alpha. That means angle between B and C is 180 degree minus alpha. So this is how we can calculate, angle between two vectors. Hope now you have completely understood that how we can calculate angle between two vectors. Let's take some more questions related to angles. This is A, this is B vector, and this is C vector. A vector, B vector, and C vector. This angle is 60 degree. So what will be the angle between A and B? Now it's very simple. What is the angle between A and B? You can parallelly shift it like this. So this angle will be the angle between A and B, that is 120 degree. Now suppose this is 80 degree. So what is the angle between B and C? Very easy. Now you can shift it like this. This is C. Can we shift B like this? Now this becomes how much? 100 degree. So this is 100 degree, right? So this is how we can calculate angle between two vectors. Hope you understood this concept completely and there will be no any problem with this concept, right? And okay, let me ask you one more question. So now suppose this is A vector and this is B vector. This is A and this is B, and angle between this is 60 degree. Now what is the angle between A and B? You can easily tell that angle is 60 degree, but can't we say that this will also be the angle between A and B? That is 360 minus 60, that means 300. Can we say that 300 is the angle between A and B? See, angle between any two vectors is by default restricted between 0 to 180 degree. 0 to 180 degree. That's why this is not the angle between A and B. So if we have to find the range of any angle between two vectors, that will be 0 theta 180 degree. 0 greater than 0 less than equal to theta less than equal to 180 degree. That is the range of angle between two vectors. It means angle between any two vectors can't exceed 180 degrees, right? So that's all about angle between two vectors. Now let's understand types of vectors. Types of vectors. Okay, so the first is equal vector. Equal vectors. By name you can say that vector which has same magnitude, same direction and same unit. Vectors which has same magnitude, same direction and same unit is called equal vectors. See, I'm not writing it that what is equal vectors. You can write it down by yourself. I'm just taking some examples. So see, suppose this is the block where a person exerts a force of 5 Newton and another person also exerts a force of 5 Newton. Here both is applying force of 5 Newton in the same direction, that is east. That's why suppose this is A and this is B. So we can say that vector A and vector B is unit vector. Why so? Because its magnitude is same, its direction is same, as well as its unit is also same. So this is what equal vectors. Suppose this is C. By applying the force of 5 Newton or 5 Newton by A and B, it is moving with the speed of 10 meter per second in the direction of east. Okay. So can we say that vector A, vector B and vector C are equal vectors? No, because although suppose this is also 5 meter per second, although it has same magnitude, it has same direction, but its unit are different. That is why it is not equal vectors. Okay, so now let's move to the another type, that is parallel vector. Parallel vector. What is parallel vectors? Parallel vectors are those which has same direction. Parallel vectors are those which has same direction. So now let's take this example. Here you can say that vector A and vector B and vector C are parallel vectors. Why so? Because the direction of vector A, direction of vector B and direction of vector C is same, that is east. That is why vector A, vector B and vector C are parallel vectors. So the parallel vectors are nothing but those vectors which has same direction. So can we say that all equal vectors are parallel vectors? Yes. Why so? Because the direction of equal vectors is also same, and parallel vectors are also those vectors which has same direction. So we can say that all equal vectors are parallel vectors, but all parallel vectors are not equal vectors. Okay. Now the third type is anti-parallel vectors. Anti-parallel vectors. Anti-parallel vectors are nothing but when angle between two vectors becomes 180 degree, that is called anti-parallel vectors. When theta equal to 180 degree, theta is what? Angle between two vectors. Then it is called anti-parallel vectors. Suppose this is the A vector and this is the B vector. So angle between A and B is 180 degree. So this is called anti-parallel vectors. Anti-parallel vectors. When two vectors has angle of 180 degree between them, then it is called anti-parallel vectors. Fourth is negative vector. Negative vectors. Negative vectors are those vectors which has angle of 180 degree and negative vectors. Okay, so hold on for a second. So negative vectors are those which has same magnitude but has opposite direction. Suppose A is the vector of 5 meter per second in the east and B is the vector of magnitude 5 meter per second in the west. Then we can say that vector A and vector B are negative vectors because these two vectors have same magnitude but has opposite direction. So this is what we call negative vectors. Then we have another type of vector, that is co-initial vector. Co-initial vector. Co-initial vectors. What is co-initial vector? When the origin point of two vectors are same, then that is called, co-initial vector. When origin point of two vector is same, that is vector A and this is vector B. This is vector C. All these vectors are originating from this point. Suppose this is O. Then this is called co-initial vector. When all vectors, when the initial point or origin point of vectors is same, then this is called co-initial vector. We have another type of vector, that is coplanar. Coplanar vector. When vectors are in the same plane, then that is called coplanar vector. Suppose this is vector A, this is vector B, and there is another vector which is like this. This is two-dimension figure, two-dimension. Suppose we have to suppose this is C vector, then these are not coplanar vector, because A and B are in the same plane but C is in the another plane. So when two vectors or more vectors are in the same plane, then that is called coplanar vectors. Okay, let's see here. Suppose this is A vector, this is B vector. Okay, this is B vector, and there is another vector which is like perpendicular to this in another plane. Then that is called that is in the another plane. So that is why we can't say this is the coplanar vector. So coplanar vector is what? Vectors which are in the same plane. Okay, that is called coplanar vector. Then we have zero vector. What is zero vector? Zero vector are those vectors which has zero magnitude. Zero magnitude. And its dimension is arbitrarily. Its dimension is arbitrary. Means it can take any direction. This is what we call zero vector. Then we have unit vector. Unit vector. So unit vector is nothing but a vector of magnitude 1. A vector of magnitude 1 is called unit vector. It is, suppose A is a unit vector, then we can represent it as A cap. This is how we represent unit vector. So unit vector is what? Any vector which has a magnitude of 1 is called unit vector. These all are types of vectors. Okay. Now let's understand polygon law. Polygon law. What is polygon law? Polygon law is nothing but it is the way to calculate the net or sum of vectors. Sum of vectors. Suppose A is a vector, then there's another vector V, then there's another vector C, this is B vector, this is C vector, then we have D vector. So what will be the net effect of this vector? That is sum of these vectors. So polygon law says that the sum of these vectors are nothing but this will be the vector which joins tail of the first vector and head of the first vector. Sorry, tail of the first vector and head of the last vector. So this is what polygon law. Suppose this is net vector, that is R, resultant vector. So this is, we say, the sum of these vectors A plus B plus C plus T. So what is polygon law? When there are numerous vectors and we have to add all these vectors, then the resultant vector is what? It is that vector which joins the tail of the first vector and head of the last vector is called polygon law. It's called resultant vector. This is what polygon law says. But the order should be same. It can't be like this is a vector, then this is b vector, then this is c vector, then this this is d vector. Means direction or alignment should be same, then only we can say that when we have the vectors of the same order and we have to give the net effect, that is resultant vector, that will be the vector which joins tail of the first vector and head of the last vector is called the resultant vector. This is what polygon law. Okay, now so we can say that this R vector is what? Sum of vector A plus B plus C plus D. Okay, this is what we say resultant vector. Now suppose we have vectors like this, A vector, B vector, C vector and D vector. What will be the resultant vector here? As I told you in as polygon law says, that resultant vector will be that vector which joins tails to head. Here the tail of the first vector, that is this point, and head of the last vector, that is also the same point. So this is what zero vector we say. Zero vector. Direction is arbitrary here. So this is how the concept of zero vector has originated. That when we have different vectors and the origin point of the first vector and the ending point of the last vector, or head of the last vector is same point, then the resultant vector will be zero vector. So this is what zero vector, right? Okay, so I thought now you understood that what is polygon law. So this is the way to calculate the net effect or net resultant vector. Now let's understand triangle law of addition or vector law of addition. Triangle law of addition. Okay, so this is A vector, this is B vector, and we have to add these two vectors A and B. Then the resultant vector will be this C. C is what called resultant vector. Okay, hold on. So this is what triangle of additions. Hold on. Direction will be this vector, right? So C vector equals vector A plus vector B. This is what triangle law of addition. When we have two vectors, which depicts or represents side of triangle, then the third tail or third side of the triangle which joins tail of the first angle or tail of the first vector and head of the second vector is called resultant vector. So this is what we call triangle law of addition. Okay, let me ask you some question. Suppose this is A vector and this is B vector, and you have to add A plus B, A vector and B vector. How you will add? So see, this is A Now you can shift parallelly b. So suppose if we are shifting b like this, ultimately it comes this way. This is b, so this is theta. Or either you can now the sum of angle the sum of vector a and sum of vector b is what? If you have to know, apply the concept of triangle of addition. How you can do that? In triangle of addition, we have when the vector b, head of the first vector and tail of the second vector joins, then the third vector or third side which joins the tail of the first and the head of the last is called sum of that two vector. So if we shift parallelly a, so this becomes like this a. Now this is a and this is v. So this angle, sorry, so this side c will be the sum of vector a and vector b. So this is how you can represent the sum of two vector. You can shift parallelly and joins the tail of the head of the first and tail of the second, then the side which joins head tail of the first and head of the last is called the resultant vector or final vector or net vector, right? It is just different name of sum of vectors, resultant vector, or vector sum of two vectors. This is what we say in different way, the resultant vector, right? Okay, suppose we have to represent a plus minus b, or either you can write it as a minus b vector. So see, if a is like this is a vector, and b is like this is b vector, then how you can represent a minus b vector? A minus b is what? A plus minus b. So if b has this direction, then minus b has this direction, right? Now shift this parallelly, so it look like this. This is a and this is minus b. Now the sum of a and b will be what? This is what? C vector, the tail of the first and head of the last. Direction will be a to this is the direction of resultant vector. So C vector equal to a minus b. So this is how you can represent sum of vector, difference of vector, right? Now let's understand parallelogram. Parallelogram law of addition. Say before this, we discussed that when we have to add two vector like a and b, then this vector which joins tail of the first and head of the last is called resultant vector. C equal to a plus b. Now if we have to calculate magnitude of C vector, magnitude of C vector, so we can represent it as mod C, or simply we can write C. Magnitude of A vector, we can simply write it as A or A. Magnitude of B vector, we can simply write it as mod B or P. This is the way to represent magnitude of vector. Now we will calculate, suppose this is what? Vector sum. Now if someone asks you what is the magnitude of C here, so how you can calculate that? This we will calculate by parallelogram law of addition. Okay, and see how you will calculate the net effect or net resultant vector. Okay, let me erase this first. So parallelogram law of addition. See, this is A vector, this is B vector. The our purpose is to make it parallelogram first. What is the purpose of here? We have to make parallelogram here. Okay, so can we apply the parallel shifting here? Yes, we can apply. Suppose this angle is theta. This angle is theta. So this is what angle between two vectors, this theta. Why? If we shift A parallelly, so it look like this. So this angle is theta, this is B and this is A. So this is the angle between A and B vector, that is theta. Now shift this parallelly. Can we shift this like, and can we shift A like this? Yes. So see, this is our B vector, this is A vector. Then parallelogram law of addition says that when the tail of two vectors joins, then the diagonal of the parallelogram is the resultant vector. So this is diagonal of this parallelogram. This is what we say resultant vector, that is R. R is what? R is the sum of A plus B. This is the resultant vector and this is the parallelogram law of addition. Now how you can calculate the magnitude here? See, this is theta, so if we shift like this, then this whole will also be theta. Can we say that? Yes. Now draw perpendicular here. This is 90 degree. Can we say that? Yes, this is 90 degree. Suppose this is O, this is P, this is Q. So in triangle OPQ, in triangle OPQ, see here, what is the triangle OPQ? This is O, this is P and this is Q. This is this is P. So this is triangle OPQ. Let me write it as clearly. This is Q, this is O, this is P, this is 90 degree, and this look like this. This is A vector. Let's say this point it as OPQRS. Okay, so in triangle OPQ, this angle is what? This is, see, this whole angle is theta. This whole angle is theta. Let's say this is alpha and this is beta. Alpha is what? Alpha is the angle between resultant vector and vector A. Hold on, let me write it. Theta equal to angle between vector A and vector B. Alpha is angle between vector A and resultant vector R. and beta equal to angle between B vector and resultant vector. Now let's see how we can calculate magnitude here. See, in this triangle QP, and this is what, and suppose this is S. So in triangle QPS, this we have already told you that this is theta, right? This is theta. So in triangle QPS, see, this is our A vector, this is our B vector, and this is what, resultant vector R, right? So in triangle QPS, sine theta equal to QP upon PS. Sine theta equal to QP upon sine theta equal to what? This QP upon this B, right? QP upon B. That means QP equal to B sine theta. B sine theta. Similarly, cos theta equal to what? Cos theta equal to PS upon QS, right? PS upon QS. PS upon QS. Now cos theta equal to, what is PS here? PS is nothing, and what is QS? QS is B. So this becomes PS upon B. That is PS equal to B cos theta. B cos theta. Now let me write the, draw the triangle here again. This is Q, this is P, this is S, and this is O. This is B vector, this is R vector, this is A vector. PS is B cos theta, and QP or PQ is B sine theta. So this is B sine theta. So in triangle QPO, in triangle QPO, you can say that this is what, right angle triangle. This is 90 degree. So in triangle QPO, R, that is hypotenuse here. So R square equal to OP square plus PQ square. Can we say that? Yes. R square equal to OP square plus PQ square. OP square plus PQ square. So this is R square equal to, OP is what? OP is OS plus SP. OS plus SP. OS plus SP whole square plus PQ square. Now R square equal to, OS is what? OS is A, and SP is B cos theta. So A plus B cos theta. A plus B cos theta whole square plus PQ square. PQ is what? PQ is B sine theta. So plus B sine theta whole square. Hold on. B sine theta whole square. Now from here you can write it as R square equal to A square plus B square cos square theta plus 2AB cos theta plus B square sin square theta. Can we write it as? Yes. So now this becomes R square equal to, see here, A square plus B square cos square theta plus 2AB cos theta plus B square sin square theta. Here we can write it as A square plus B square cos square theta plus B square sin square theta. B square cos square theta plus sin square theta. How? We have taken B square common from B square cos square theta plus B square sin square theta plus 2AB cos theta. So this becomes A square plus B square cos square theta plus sin square theta is 1, that is it becomes 1. So A square plus B square plus 2AB cos theta. R square equal to A square plus B square plus 2AB cos theta. From here R is under root A square plus B square plus 2AB cos theta. This is the magnitude of resultant vector. So this is how you can calculate magnitude or net magnitude of resultant vector. If we have two vector A and B and the angle between that is theta, then the magnitude of resultant vector will be under root A square plus B square plus 2AB cos theta. And I have derived how you can calculate, how we have formulate this formula that r equal to under root A square plus B square plus 2AB cos theta. Now from here you can calculate angle between resultant vector and first vector. What is angle here? This is alpha. This is alpha. Alpha is the angle between, what is alpha? I have already written it. Alpha is the angle between vector A and resultant vector R. So tan alpha equal to C. Tan alpha is what? This is alpha. This is alpha. This is alpha. So tan alpha is in triangle QPO. In triangle QPO. Tan alpha equal to C. Here this is alpha. So tan alpha equal to PQ upon OP. Right. So PQ is what? PQ is B sine theta upon OP. OP is what? OS plus SP. So OS is what? A plus SP. SP is B cos theta. So this is what? Tan alpha. So if we have to calculate, angle between resultant vector and first vector, that will be B sine theta upon a plus b cos theta. From here alpha is tan inverse b sin theta upon a plus b cos theta. So this is how you can calculate angle between resultant vector and the first vector. Hope you understood this concept, how we have formulate the formula that resultant r equal to under root a square plus b square plus 2ab cos theta. You can try this by yourself. Okay, so see, this is all for today. We have covered all the basic concept of vector, that is what is vector. Then we have discussed different type of vectors. Then we have discussed about how we can add two different vectors. Then we have discussed polygon law, triangle of addition, parallelogram law of addition. This is all the basic concept related to vectors. In next class we will solve some problems. We will take some further concept and problems which has been asked in recent exams. Right, till then, bye bye, good night.